out of those derivatives, those are the only things we know how to take a derivative of. So basically, if it's written as a polynomial, that's like the first three up there. Technically, I probably wouldn't even have needed to have written down the top two, but I just figured I would, because some people like to learn them separate. But to me, they're all power rule. So power rule covers a lot of derivatives. E to the x is a different derivative. Ln of x is a derivative. And then there are the 6 trig functions. Those are the only actual derivatives we know how to do. Did I forget one, by the way? I was trying to think of them off the top of my head. I don't think I did, but... So we've only learned a certain number of derivatives, I guess. On the right-hand side in blue, the product rule and quotient rule is what we were learning for the last week or so. Those aren't actually derivatives. Those are just a formula to tell you how to take the derivative of a complex equation. Like if your function is written as 2 multipliers, the product rule would work to find the derivative of it. But like the product rule itself isn't a derivative. It's just like a method of finding a derivative from a certain an equation written a certain way. Same with quotient rule, it's the exact opposite. I mean, it's the exact same thing, except it's when it's written as a fraction. The third helper that we're going to learn today is the chain rule, which arguably will be the most important one. It's also going to be probably slower to learn. And I would bet at first glance. What? Oh, packet, sorry. Did I give anybody packets?
No.
Yeah, that's what I thought. You can still take it, it's not like... Yeah, I'll hand out the packets in a second. So the chain rule, it's for composite functions. Oh, go ahead. Yep. It's for composite functions, which I know if you hear composite function, most people aren't going to think much of that and or whatever. But actually a good majority of our equations are written as composite functions without you realizing it. And so taking the derivative of a composite function, it's relatively straightforward. But like me personally, I guess the equation's written up here on the board too. Me personally, this makes it feel more complicated to me than what we're actually going to do. I know you guys aren't the best at notation, and that's what this is heavy on, right? F prime of g of x times g prime of x. This is what you would get if you take the derivative of f of g of x. And I know just glancing at the equations, that's not super helpful. I suppose it would be helpful if we go through the notes and you guys have it. Honestly, I forgot I didn't hand them out those. And never fear, this one is a lot lighter than the last one. 3 and 4 are both smaller packets. Not that they're tiny, they're smaller. Six. Maybe 8. I don't know. Packets are actually all on the back wall right now. I ordered them for the rest of the year because I'm tired of, I would say 8 by the looks of it. 6 or 8. Correct. 2 was very slow because we were first learning the derivatives. Same with 6 is, 5 is when we first learned integrals. So it's like spread out. I need to erase that calendar. I don't know if you guys are trying to debate it. we're not going there yet. Oh, yeah, please ignore it. That was our goal. Our goal was to finish 3 by the trimester. We're actually not going to be terribly far off. There's only 5 sections. Undecided. We decide as we go, to be honest. We generally do it different every year. So it'll probably be 3-1 to 3-3, but maybe if things are moving fast, we'll just do 3-1 to 3-5 as one test instead. I don't know. We'll see. Other years we've had like a quiz rather than like a middle test, a quiz in the test category, so it'd be like a 1-page small one, something like that. Okay, what's written in bold down here at the bottom is exactly what you're going to end up doing. It says multiply the derivative of the inside function by the derivative of the outside function. Now that sounds super easy. Where some people get caught up is understanding what's an inside function, outside function. So we're going to do this example 2 different ways. 5x plus 3 squared is actually a composite function. Like I said, we've done ones like that a bunch of times before, but something that's relatively simple like that can be done 2 ways. So if we don't use the chain rule, we can FOIL it out. Okay, so 5x plus 3, I would need to FOIL it out first before I can do anything. That would give me 25x squared, 30x plus 9. And then we could do the derivative with power rule on each individual term. Like, I would bet that's how some of you would do it on a test anyway, because you'd probably feel more sure about that method, because you've done it many times. So we'd get 50x plus 30. Like, not terrible, not bad. This one is just probably dependent on how good you are at FOILing, because it's easy to make the mistake of squaring just 5x and 3. So, okay, what we're going to do now is, this is going to be called the chain rule, and we're not going to take it apart. So I'll try to write it color-coded so it's easier for inside-outside. The outside function is going to be x squared. But instead of an x, we placed in something, right? Oh, quite a little. Surprise, there's a different schedule today. Yeah. What? Oh, oh yeah, outside inside functions.
Can I have a packet?
Yeah. Oh yeah, you too. Yeah. Okay. There you go. Thank you. Presents. The outside function is going to be the square, because that would be written as x squared. But instead of an x, we would put an entire different function that would be 5x plus 3. So the inside function is going to be 5x plus 3. And then that's kind of how we're going to view this. So if I do the derivative, I'm going to take the derivative of the outside function first, which is the squared. So the way I take the derivative of squared would be power rule. So it would be 2 times, keep the same inside to the first power. And then I'm going to multiply by the derivative of the inside function. So the derivative of 5x plus 3 would be 5. And then if we simplify this, first power, we don't actually even need to write that there, which is 10 times 5x would be the 50x. And then 10 times the 3 would be the 30. Now, I would say offhand, neither one of these is like a huge benefit or quicker or anything. But that's because we're purposely trying it on a simpler problem. Once these problems get really complicated, you often don't even have a choice. You have to do chain rule because it's going to be too complicated.
So where'd you get the 5 at the end?
At the end?
Yeah.
Okay, so chain rule. Ooh, look at this. I'm going to be all fancy, like pretending like I'm doing real. Whoop. So the derivative of the inside function is everything I have written in blue. And then times the derivative of the outside function. Oh God, I did that backwards. It was set up so nice. You know, I didn't even notice it was written that way. I always do the outside function first. Have I been saying it backwards to you guys? Or have I been saying it correct and I just didn't even read that one?
If you scroll down, it says it the other way too.
Okay. I traditionally multiply the derivative of the outside function first, because that's kind of the main way the thing is written. So like to me, the squared is the important part of this. And so I would start by doing the derivative of something squared. And that would be the power rule by doing 2 times something to the first.
Why do we know the square is the outside function?
I don't know, literally outside? If something is in a grouping symbol, so like a parentheses, a brackets, a root symbol, if it's somehow grouped together, that's what we would consider the inside. Because the grouping symbol is what would have replaced the X. I didn't ignore yours, Owen, though. I was trying to just fix the colors. So the 5 at the end came from taking the derivative of the inside. Yeah, go ahead.
What, the inside front? Oh, I see.
So the inside the parentheses is 5x plus 3. And that's going to be considered the inside. The outside function is going to be considered the square. And honestly, I don't care if you guys learn this as inside outside. When I was taught this, that wasn't the phrasing. When I was taught this, we were just taught that the squared is the main part of this function. Because if I were to do like PEMDAS or something like that, I would have to focus on that square. Or slash the parentheses would be first in PEMDAS, but that's all grouped together, so that would be kind of like a separate thing.
At like what point there would you put like F prime of X, like, cause I,
Do you want me to try to match it up to the actual formula? Is that what you're saying?
well, like where you put F of X, like, isn't that, like before you did the 2, 5x plus 2, would you do like F prime of X there? Yeah. Do you know what I mean?
The terrible part is this is labeled F of X. So let's, what the heck? Oh, I got it on highlighter. Okay. Yep, that's good. So let's say f of x, we'll use the u and the v that I think you guys have probably seen sometimes. U of v of x. So v of x would be considered the inside function. U is the outside because it's basically literally outside of it. The derivative, I don't even have room. The derivative of f would be the derivative of the outside, u prime, with the same inner portion times the derivative of the inside. So like down here,
Would be like for the two. Is where you would put, like, the derivative of the function.
like labeling?
Like, just how on the other side,
Oh,
you put f prime.
I know what you're saying. I wrote this terribly. I was focused on doing the derivative
Okay.
that I wrote the notation terribly wrong. I see what you were saying now. I will move things because I put them in the wrong spots. I didn't even notice that because I was so focused on trying to teach you the notation, or I mean the chain rule, that I put everything in the wrong place. Okay.
Sorry, I didn't mean to make it complicated. I was just.
Oh, no, it's not complicated. I wrote it wrong, so I want to make sure it's correct for you. Like, I could see when I was correcting the test that a lot of you didn't even try to simplify things. And I don't know if that's because a lot of times I don't have time to simplify, so I might skip some of those. I was counting on the fact that you guys are checking your homework answers, because homework answers are always simplified. But I feel like in class more, I'm going to make an effort to take things as far as they should always go, even if it means less problem set. So here's what I should have written. And that's what you're showing.
Yeah.
Gotcha. Correct. This was the original function, so then I would write that as the derivative. I don't know. I'm sure this probably seems strange at first too. I'm not worried about that. Something else somebody wants me to say about that problem? I mean, obviously we can do more together, but
Wait, why is there a derivative like on top of 5x plus 3?
you mean like why didn't this 5x plus 3 get changed?
Yeah.
It's just the first power.
Oh, that's the first power.
Oh,
Yeah, that.
gotcha.
Oh, okay. I thought that was a derivative.
I wanted to write that there because otherwise I feel like some people wouldn't even know what happened to the power or power rule. Should we go to another problem to try? Okay. So looking at A. I mean, the notes for this section aren't very long, but I'm going to tell you it's going to take us 3 days to go through this section. Because they're all going to feel very, very foreign to you, very different, like, they're not gonna feel like regular derivatives, even though these are the only derivatives we know, like the only process. What? I see it's not totally gone, huh?
It's doing all right.
It sounds a lot better than testing. I think we'll all agree that. First thing I'll do with A is I want to rewrite it so that it's in the form of when we do derivatives, right? Like any square root we had before, we purposely wrote as a power. So that's the first thing I'd like to do. Should I don't know if this is too early. Anybody tell me how I should rewrite this?
X squared minus 1 in parentheses to the power of 3 over 2.
Perfect. So the square root means it's going to be a half. And then the cubed that's on that parentheses would become the 3 on the top. So, you may have something important going on, I don't know, but
No, I just put this away.
that's what I know, that's what I said, you may have something, I'm not gonna try to pretend. What would be considered the inside function on this one?
The inside function?
Yeah, I don't know if this will help, but maybe I'll write it off on the side for you guys.
I think it's x squared minus one.
Perfect. Okay, if there's a parentheses, that's literally going to be the inside. Most of the time, the inside is semi-obvious because it has to be grouped together. Okay, so inside, x squared minus one. Would this help if I wrote this, kind of like when we did ff prime, gg prime? You don't have to do this, but if it helps you, yes, do it. The outside is the 3/2 power. I don't care how you wanna write it. I'm gonna write it like this for you guys so that you kind of understand where I'm coming from. But the outside power is going to be something to the 3/2 power. So the outside function is what kind of dictates how we approach it. Because I've got a power, I need to do power rule. And then that's what I would focus on next. So when I'm doing the, I did, okay. When I'm doing the derivative, I would do the derivative of the outside first. So something to the 3/2 power would be 3/2 times something, and then the power is going to be 1/2, okay? So that works exactly the same. Now this is where some students get totally lost and confused. I get why. The inside will stay the same. The most common mistake by far is to take the derivative of x squared minus 1 and put it in there and be done. I get why, but you're not going to. So this stays x squared minus 1. We did the derivative on the power portion of it. And then now we're going to take times the derivative of the inside, which would be 2x. Now, if the derivative of the inside is a bunch of things, you put it in a parentheses. I don't know if this would help or not, but derivative of outside. This is how I mentally approach these. Like, you're 100% allowed to just write down everything without showing work, because this is the work. And some of you may need to write things down like this to keep all your information straight. If that's the case, go ahead and do it. It's not an issue. What time do we get done? 6. Okay. I thought we would have time to do a couple problems and then have you try like one on your own or something, right? We are not done, and this is where chain rule usually goes horrible for most everybody. It says, you guys hate the algebra. You hate the simplifying. This has way more simplifying than what we had before. So now we're got to simplify this. Everybody have a thought? Yeah, just the two normal things that are on the outside, no powers, no nothing, so we can multiply them together. So that would be 3/2 times 2x, 6/2, which is 3x.
Would we do the power first?
Um,
Like 1/2?
what do you mean by do it?
Like, multiply that by x squared minus 1.
Got you, no. I'll write something over here, but I'll erase it. If we had things multiplied on the inside, and we had a power, then you can put the power on each. I think that's what you were trying to say, right? Yep. If there's addition, like separate terms, there's nothing we can do. So the only thing we actually can do to simplify that is either A, write it as a root symbol, or B, leave it like it is. This one doesn't have much to simplify. If it was a negative power, we would probably be asked or shown to move it to the bottom. But it's not. So we can write it as a 1/2 power, or we can write it as a root. It's your preference. On the AB test for multiple choice, they traditionally will change it back to a root symbol for whatever reason. It's not more correct or less correct. They usually do. I don't know, how are we feeling about that one? Okay? Why don't, do you guys feel like there's a place where you can try one? I guess if it helps you, start off by figuring out what's the inside outside. And or maybe you even need to rewrite it to be able to do the problem, because we did that over here. And then try to do the derivative with that format. And this will become second nature after a while. It's just very strange right now. Yeah, try B on your own. Oh, for the next one. Parentheses, inside. So the outside is what's throwing you off?
Yeah, because this is the outside square, so that would be
That's part of the outside. So the outside function is technically -7 something to the -2 power. Basically, the something or the parentheses is what you mentally treat as an x. So if I were to erase that parentheses and just put an x in its place, that's what you would consider the outside function. And we're not gonna try to rush this. I fully plan on doing all of these problems with you. That's why it's gonna take 2 to 3 days. I'm sure some of you are gonna catch on quicker than others, and that's what happens for every topic. This one might have a little more simplifying, I'm not sure.
Can you not distribute the -7?
Nope. Because the powers on that parentheses, the 7 just stays out front because it can't go in the parentheses unless it's the first power. You guys want me to do it up here? Do you want me to give you some time? I don't want to rush you on it, don't know how long it takes. I bet some of you are probably stuck. So when I do it, I usually will do it without actually filling out the parentheses. Because I don't want the information in there confusing my brain with other numbers and letters. So I usually do it with a parentheses being an x. So like in my head, I'm +14 something to the -3. And then I kind of start filling in. So I rewrite the exact same parentheses. At the end, multiply by the inside, derivative of the inside. I take it back, this doesn't have much simplifying to do at all. And like I said, once you get used to this process, it'll be second nature. You probably didn't even notice at this point that every problem we had was plain X's. Like, every time we had a power, it was only on an X. We never had a power on other things. And that's because you need to use this method, chain rule. But there is songs for this as well. What was it? Was it the Grave? You guys don't know the California Raisins anymore, probably. For some reason, California Raisins were like a huge hit when I was younger. I don't know what that would have been. Probably early 80s, mid 80s. And they always had the California Raisins sing the song by, what is it? Not the Temptations. What's that song that goes chain, chain, chain? I don't even know how, I'm such a bad singer, I have no idea how to even like reproduce it. It's an old song. Okay, if you type chain, 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 it'll come up on your phone. It's really gonna bother me now, who's saying California Raisins? They had the Raisins as singers, and they always had them sing these old songs. But one of them is about a chain, like a chain gang. And so there's a chain gang song for doing chain roll. I had seen the teacher that used to be here that also taught Calc that retired. He always used to teach chain roll with peanut M&Ms. So the outside shell was outside function. The candy coating, well, actually that'd be a regular M&M, I guess. So the outside shell was the outside function. The chocolate was the inside function. And so that was, he used to do it with M&Ms all the time. You're going to get questions that have multiple layers of chain roll eventually. And so then that's when he would switch to peanut M&Ms, which had 3 layers. Now, to me, one, it never clicked with my brain. And so it would be stupid for me to try to teach it if it never even clicked with me. Also, a bunch of people are allergic to peanut stuff now, so but try not to kill you off. All the problems we're gonna do here are just gonna be set up with one chain roll step. We'll get to more complicated. But, like I said, if you wanna look up songs for chain roll or look up, I am never against it at all. There's nothing bad about you guys trying to find a video online of teaching a topic, because hearing a different person explain the same idea might just absolutely, vibe with you a lot more than me trying to explain it. There's nothing wrong with that, that's pretty normal. If there was a great way to explain every single idea, well then every single teacher would be able to teach it that same way. But like, say for me, I have to be able to teach something the way my brain thinks of it. And that's gonna be the only way I'll be able to try to explain it more thoroughly. And so try to watch other videos. If this chain roll makes 0 sense to you, I definitely recommend you watching other people try to explain it. I didn't want to go any further. This is very slow. If you feel like trying to start the homework this weekend, you're welcome to. Otherwise, on Monday, we're basically gonna just go through these forward and then try to go from there. I take it back. We have a 2-layer, multiple layer chain rule down there. All right, ignore F. But I'm guessing the first couple of questions in the homework do not. And we'll get to that. But so nothing is assigned tonight if you don't want. You guys just got rushed through a lot of information in the last couple weeks to get to that test. I don't feel like melting your brain immediately afterwards. So if you probably need time to recover, essentially. And then on Monday, we'll try to hit this again.